Hey, welcome everybody to today's webcast brought to you by eWeek and sponsored by Capsulate on climbing towards automation, the SOC hierarchy of needs. Really important topic, I'm sure, for all of you who are with us today and on demand, because we are being massively attacked and yet we're pretty much under-resourced. So, efficiency, prioritization of where we allocate our human resources is really, really important. You're at the right place. We've got two great experts that you're going to hear from today. From our sponsor, Capsulate, we have John Viego, who's the company's co-founder and CEO and real industry veteran. He was SaaS CTO at McAfee, has written a couple of books that you may even know about secure software and OpenSSL. He co-designed GCM encryption mode, which is obviously used for a huge percentage of encrypted web traffic. So really looking forward to hearing from him, especially as regards protection against exploitation of previously unknown vulnerabilities. And then joining John as guest speaker will be Amy DeMartine, who's principal analyst serving security and risk professionals for Forrester Research. And what I like about Amy is really her breadth of experience. She's been on sort of the technology side as a product manager at BMC and HP, but she also has served infrastructure and operations professionals, so she really understands kind of the organizational and process dynamics and is actively engaged in helping us transform those dynamics so that they're as efficient and effective as possible. One other thing I want to tell you before we begin, slides will advance for you automatically, but perhaps most importantly, this is an interactive console, so please, at any time, if either John or Amy says something you want them to elaborate on, clarify, even if they make an assertion that you'd like to challenge, feel free to submit questions as early and often as you want. Don't wait until we get to Q&A, because the queue will probably be kind of filled then. So just go ahead and get those questions in. We'd love to answer your specific concerns. And with that, John, I believe I am going to turn things over to you.
Great. Thank you very much. So when we had started Capsulate, we started by going out and listening to almost 50 large enterprises talk about their security operations, both today and where they're going in the future. We talked to enterprises of various sizes across various verticals. And one of the trends that would surprise a lot of people in security is that a number of companies are starting to go without a traditional SOC. Google is probably the most prominent example of that, but this model is being followed at Amazon, Netflix, Facebook, and lots of other Silicon Valley companies. And so we really started to dig in to the job and the difference between the two categories of SOCs, and we learned that the needs were universally the same. We, as a matter of fact, heard over and over again from both typical compliance verticals like financial and the Silicon Valley world that they saw a single hierarchy of needs with a shared vision that they were moving towards, and it's just that the Silicon Valley companies not having the shackles of the same compliance regime and were able to throw more money at it and get there faster. But today what we wanted to do was share the learnings from this hierarchy of needs. I will be talking about the perspective that we gained, sharing insights from those nearly 50 customer interviews to talk about how customers see moving towards a SOC-less enterprise. And then Amy will kind of provide more of the industry perspective after each layer. So this slide shows the model, and each layer builds on top of the other. So we're going to go through this diagram from the bottom to the top over the next few minutes here. At the very base of the pyramid is discovery. Discovery of your assets that you're trying to detect, What's not on this pyramid, by the way, is prevention. Most organizations have invested a lot in prevention, and attacks slip through whatever defenses you have, especially if it's a so-called zero-day attack, and that's where the responsibility of the security operations team starts. It's when something does slip through, trying to minimize the impact to the organization by dealing with it efficiently. And in order to be able to do that, you have to have a sense of where your organization's boundaries are. We heard in kind of the traditional IT setting, people protecting what's running in their data centers and what's running on people's desktops. Asset discovery is certainly an issue for the SOC, but there have long been a range of solutions that aren't very complete and don't stay up to date. The move to the cloud, we heard a lot of companies worried about the fact that any developer can go and deploy something with the company's name on it and have their own Amazon account. So keeping track of all the cloud provider accounts you might have, and even more so the fact that developers can just go and decide to use containers and have security relevant data passing between containers, that's not visible at a network level. So that really is kind of the base need in the hierarchy.
Yeah, thanks, John. I really couldn't agree more. The fact that we have missing assets in our inventory really is the blind spot for most organizations. And let's be honest, most organizations still use spreadsheets to try to track assets. Maybe it's automated, but it's really then automated with what you know about, what IP ranges that you've already been told about. But like John said, developers can go off and create whole new applications. Marketing can go off and create whole new applications. We've long lived with this idea of this hidden IT where developers, marketing, any part of the organization can go off and create these applications. And when they do, then as security professionals, you just have no way to protect them or to know that they even exist to do, discovery, to do, are there problems? Can you triage these problems? So fundamentally speaking, asset management is actually a security concern as a blind spot. Now, unfortunately, our tail of asset management is often a fragmentation. So security may be trying desperately to piece together some sort of asset management inventory. IT might be trying to desperately collect inventory. They might be completely separate. There might be the Excel spreadsheet. There might be the discovery tools for specific types of apps that work. And so bringing it all together is often a challenge. Now, in the past, we've had some fits and spurts with the CMDB, trying to get that automated and created, but those have long been expensive and sometimes futile efforts. So it's time to go back and look at how we automate this problem. How do we automate IT asset discovery and then share the same database between security and infrastructure and operations? Because if it's not the same, it's guaranteed to be wrong. I'll hand it back over to you, John.
Thanks, Amy. The building on top of discovery, if the real first business driver is to detect attacks, you need to have data to do that detection. Visibility kind of underpins the rest of the hierarchy. And traditionally, that visibility was provided through network appliances and happened at the network level. That visibility, even in a traditional data center, is somewhat going away. I mentioned briefly how containerization removes visibility of what's going on. between containers, but there's a huge move for end-to-end encryption, and the cloud certainly makes the network a pretty poor vantage point to get visibility. So that was something that organizations were struggling with, particularly for their production infrastructure that was moving to the cloud, because performance and reliability are so critical to people's production infrastructure, and security is more a second-order requirement. And so there's a real tension between doing better security and getting better visibility. The concern is if you put something on each cloud instance that you could impact the stability and performance of that workload, and that is incredibly bad for business. So that's certainly one challenge that is critical to improving detection in a cloud ecosystem. But I'd say that we saw plenty of organizations looking to get better visibility in their traditional data center environments as well. The pretty much universally held belief was that if you could prove that you can manage stability and performance risks, that it would be much better to have deeper visibility than you can get at the network level. So as a really simple, for instance, at the network level, you might see a payload go across the wire, but you don't know if it actually landed on a host or not. If you're on that host looking, you could certainly see it. Amy?
Yeah, thanks, John. Certainly, like you said, as we move to containers and then even farther into even serverless applications, our control over things like the network goes away. And so we don't have our traditional control points or monitoring points to give us information about what these applications are doing. So I want to take a step back and really look at containers in specific. And so we do these surveys, big surveys of developers and security, so I want to share some data that we have from both of these. The first one is, where are we with container adoption? Because a lot of organizations I talk to say, well, maybe this isn't really for us. Maybe we don't have any containers, and I'm going to tell you it's likely that you do. What we found was about a third of the organization said not only are they using containers to develop with, but we're also using it to deploy with. Now, compare this to data from just a few years ago where about only 30%, 25% were using it kind of in experimental mode while they were developing. When it actually came to production, less than 10% actually were in production. Now it's even. So what the developers are using to develop are now being pushed out into production. So that does mean that maybe you've thought, oh, we'll wait on container security, maybe we don't have to worry about it. It's probably time to start turning around and looking at what container security needs. And once again, like John was saying, because you don't have kind of those traditional control points if you've deployed your containers, for example, out into the cloud. Part of our survey out to security pros, we asked, have you suffered an external attack? And this is last year's data. We haven't published this year's data, but I can give you a sneak peek into what it looks like. I can walk you through it. But last year we asked this data, and 45% of firms said there was an external attack. Okay, then we did one click down and we said, how was this attack carried out? And the top two methods were vulnerabilities, think Equifax, and web applications. This is more like weaknesses, so think SQL injection, cross-site scripting. This year's data, which once again hasn't been published, but now when we asked, have you had an external attack, 40% said that they experienced an external attack, and when we asked how, the top two were actually flipped. So the SQL injection cross-site scripting reared its ugly head and became number one, and software vulnerabilities became number two. Regardless, what is clear is that attackers are getting in through our applications. It's almost as if we just rolled out the red carpet for attackers and said, here, come in, attack our applications, because that's where we are the weakest. And when you look at containers, they're a very specialized problem, partially because of what can go in a container. Developers can throw anything they want into a container. They can throw OSs, they can throw base libraries, app libraries. In addition to their developed code, they can include any kind of base image that they want inside of a container. And then it's up to the tools in production to really understand what is normal behavior for that container. Whatever the application developer has decided it should do, what is it that's normal? And then once it understands what's normal, then it has to understand, okay, is it acting abnormally? So for example, maybe it already has a connection to back-end databases. Okay, that's normal. But then if it starts spawning outside connections to other databases, okay, that's not normal. That's probably something we need to look into. So it's understanding, first baselining what normal is, and then being able to then alert you when it does something that is abnormal. Now, of course, the trick here is containers can be deployed very quickly. So if you think about developers, microservices and containers are usually paired together in the same conversation. So if you think about an application that's been divided into services and even microservices, and each container then deploys a service or a microservice, and you've got developers working asynchronously, deploying when they're ready, you could have new containers out constantly. And so your tools then are pushed to the extreme to understand, okay, I've got a new container, I've got to understand what's normal about it. Okay, I've got another new container, what's normal about it? And then, of course, monitoring throughout it all what is abnormal. So as we go to these faster releases, as we go to these new application deployment methods and architectures, it pushes the boundaries of our traditional visibility into what is normal and what is not normal. And with that, I'll hand it back over to you, John.
Great. So detection is really the first business use case in security operations, and this is where we've all heard about how absolutely overwhelming the job of security operations is. We talk about terms like alert fatigue, and companies talk about how they have too many alerts to ever look at. The security operations kind of taken the responsibility for doing detection away from security appliances by bringing in algorithms to help address the problem. So collecting data from as many data sources as possible, pumping it all into a data lake, and doing analytics over it. And that certainly has produced better, higher quality results than relying solely on the data coming out of security appliances and the weak correlation that SIEMs used to provide. But it by no means has really addressed the problem for most organizations. They still end up with way too many alerts, way too many false positives, way too many missed attacks. What we've seen in the highest functioning security operations teams at places like Google, they tried to improve upon the quality of detection, not just by applying algorithms to the problem, but also by improving the quality of the data. So it gets back to better visibility results in better detection. But when we talk about to customers about the business drivers around detection, the single biggest driver for better detection is to be able to minimize the economic impact of a breach that does get through all of your defenses. And the number one metric for that isn't your false positive rate or anything like that. It's about time to detection. So the drive to be able to detect something with very high confidence in real time becomes huge once you can manage the number of false positives, because you don't want to be in the position where you're looking through an entire hayfield to find the needle in the haystack. But once you get pretty good at finding needles, you want to be able to find them fast, and that's where kind of the most highly optimized security operations teams have moved towards, by both improving their analytics capabilities but also focusing on the quality of the data. Amy?
Excellent. And I seem to not be connected to the internet right now, so if somebody could move me forward to my slides. So the security operations is the experience most needed today. So going back to our big surveys where we say, hey, what are you doing? And have you experienced attacks? We also ask, what are you needing most in your organization? Last year, it was actually application security folks. This year, it's security operations. And so it's really highlighted the fact that we are struggling with the number of apps out there, the types of apps, how we're getting attacked, the varied methods attackers are coming at us, and like John said, the amount of data that we are getting hit with. And so there's not a herd of bodies that are coming to save us in this area. And so we're not going to get a flood of new security operators that will come and save us here. We really need to focus on more automated detection, automated response, because we just don't have those people. And thankfully, I'm back online, so I'm able to move forward. This is actually the NIST Computer Security Incident Handling Guide. And we often refer to it just because of its popularity. Lots of folks use this, but really it shows these different phases, a lot like the hierarchy of needs, but unfortunately in less detail. So, you've got a great incident handling, preparation, and then you've got your detection and analysis. But really, your detection analysis, because like John said, you're barraged with alerts. You've got this huge amount of data you're trying to understand. And you're trying to understand through all of these alerts what's most important. How you respond is dependent on what you know. And I know, John covered that as well. What you can, visibility depends on, then that's what you can detect. But it's really important to remember that all of these are tied together so that when you are barraged with all of these alerts, then how you respond, how important you think those alerts are, depends on what you know. And with that, I will hand it over to John.
Thanks. When we think about investigation, that really speaks to a number of different business drivers. If you think of a deep forensic investigation, typically we heard security operations teams say, we're very far away from being able to do a lot of that. We would really love to be able to, but we're so absolutely overwhelmed that we could only do that for the most egregious of incidents, and would probably have to bring in somebody else to help us out. Yet they still had a lot more day-to-day investigation needs, taking the alerts that actually come out of their analytics capabilities and try to figure out which ones were actionable, which ones required containment and cleanup, and then needed tools to help make it easier to do that containment and cleanup. So once you have any kind of detection capability, you also want to be able to use data to help make sure that detection is actually working well, and help you kind of tweak that as well, so there's a great feedback loop here. Amy?
Yeah, and to really emphasize that feedback loop, GDPR, part of GDPR is to do audit, that you are auditing your mechanisms, you're auditing your incident response. And so as we move to these more global requirements placed on us by privacy, by security, auditing is going to become more and more important. And so being able to understand, okay, where was the root cause, going back through the hierarchy of needs to the, inventory, understanding where it is, and the detection, being able to audit those steps, keep track of those steps, and like John said, to then go back and do improvement is going to become more and more important. And being able to track those and then keep those for future improvements is also important. We jokingly say that as analysts that if you really want to increase your budget, have a breach. Unfortunately, sometimes that's what it takes to really emphasize the point that, hey, we actually do need tools around detection and visibility. Hopefully you're not in an organization that is in this spot. Hopefully you've got enough resources in terms of tooling to be able to do detection and investigation and response. But what we find is if you suffer a breach, your funding increases greatly. 15% gets increased on detection itself, and then 21% on incident response, so the ability to respond. And so really it focuses on, and then 23% is on threat intelligence capabilities. So really going back through the hierarchy of needs to, okay, where did we go wrong? Where can we put in more information so that we can, in the future, be able to investigate and improve going forward? With that, I'll hand it over to John.
Great. So the tip of the pyramid for the security operations hierarchy of needs is actually being able to automate around the responses that you want to do. When we looked at the highest functioning teams, places like Google, I said they don't have a traditional security operations team, and that's because their security operations team consists only of developers. Their workflow is approximately when new classes of incident happen, they do that investigation, but then they write software that fully automates the detection and response that the company wants to take for any similar incident they could imagine in the future. And that has wide, very impactful implications. And so for the most part, they focus on fully automating whenever possible, but even when that doesn't make sense, so for instance, if there's account takeover where a legitimate user's credentials are being used, but they detect they think it's not that person, they may want to automatically reach out to that person and say, well, is this you? And automatically take action if the legitimate account owner says, no, that isn't me. So that kind of level of automation is really the holy grail of security operations, and we definitely see a lot of organizations trying to move into that direction, starting off by automating the SOC workflow with security orchestration tools. And I think that's kind of a very typical approach to the problem. When you look at people's maturity relative to the hierarchy of needs, they do better the lower they are in the pyramid, but they have aspirations of climbing up to the top and are trying to do a very little bit all the way up the pyramid. Amy?
Excellent. Well, let's walk through an example of what non-automated versus automated response looks like. So this is an example of looking at a possible phishing email. And so if it's not automated, then the analyst has to review the email, create a ticket, and then start extracting these IOCs, or the indicator of compromises. And so they go through that. They've got to update the ticket. They've got to do some external maybe they look at an external source, update the ticket again, looking at another external source, and then the analyst closes it out. If you use tools, for example, John was saying there's sort of weak correlation provided by SIM tools. With security automation and orchestration tools, a lot of this can get automated. And I know this peak of the security operations hierarchy of needs is kind of the nirvana. It's really where we all want to go. And like John said, if you can't automate all of it, automate part of it. Any kind of automation is going to benefit your organization. So when we look at this same example, but we look at it with security automation orchestration tools, for example, all of that stuff like reviewing emails and creating tickets and updating the tickets, all of that happens automatically. And so only if the tool is not able to automatically mitigate it, they're not able to look to see if there's any malware, were there additional recipients of this phishing email, all of those things, then only if it's not able to be automatically mitigated, then it gets rerouted to an analyst who's then able to review it and then spend time on it. But if at all possible, it went from 25 minutes to 0 minutes. And that's a huge saving when you think about all the different attacks that may be coming in at an organization. And with that, I believe I will hand it off to John.
Well, that's it for our core content. I wanted to say that Capsulate's mission is certainly helping companies wrestle with the security operations hierarchy of needs, focusing on protecting their production infrastructure wherever that lives. And we certainly cover this content and in more detail on our blog, and I certainly invite you to look there. With that, I'll turn it back over to Lenny.
Hey, thanks so much, and I think you guys covered an awful lot of ground really concisely, a lot of interesting assertions there, and some questions have come in. If you're on with us and you haven't submitted a question yet, please feel free to do so. Also want to remind you, you're going to get a post-event survey. If you could complete that, that would be great for us to just get a sense of how we can keep improving these presentations. John, I think the business is often putting SOCs under pressure to kind of be super preventative about attacks and are imagining there's some kind of perimeter that if the security people get right will somehow become impermeable. But it sounds here like you're advocating for a lot more emphasis on mitigation, speed to detection and remediation. Do you want to just, you did that up front, maybe you want to just underscore why you're placing the emphasis there rather than on some hoped for impermeability?
Well, so I would say that prevention is certainly job one for organizations, but there's a very clear legacy of people investing tremendously in prevention and still getting massively owned. And so where we focus today is on the role of the security operations team, which traditionally hasn't owned the job of prevention, but they're the ones who are the final layer of defense, trying to detect the breaches that actually do occur and respond to them. And that can drive better prevention as you better understand the attacks that people actually launch against you. But detection and response never goes away.
Yeah, I just want to echo those comments of John's. We will never have a perfect environment. We will never have perfect code. We absolutely have to be able to respond quickly to incidents. And so he's right. Prevention is job one. If you can't prevent an attack, at least make it so that attackers can't get to everything. So you can actually kind of make the attack more limited with good prevention. But once again, you're never going to have a perfect environment and a perfect applications. We will always have to be able to respond.
Yeah, and Amy, sort of along those lines, we have another question here, which is when we're deploying advanced detection, right, we have this issue that we want to reduce false positives so that we're not chasing a bunch of stuff we don't have to chase, but we want to avoid the other problem, which is false negatives, right, and missing something. So how do we tune our systems so that we're both avoiding false positives, but that we are catching the true positives?
Right. It goes back to, I believe, correlation. So I think we can get false positives more when we immediately jump on, oh, we've got an alert, it must be a problem. And really we want to see multiple kind of indicators that increases risk. And you also want tools to be able to tell you that, to do that correlation. But actually in my interviews, what I found is folks in the SOC want more data, not less, that it is a big data problem to solve. But actually, if you get lots of data, then you're able to do those correlations and see the different, this attack is coming, I know, because I've seen multiple indicators rather than I'm relying on a single indicator. So in my interviews, I've actually found that more data is better. So don't tune it per se. Make sure that the tools that you're getting are able to do that kind of risk analysis in terms of being able to tune up or tune down risk depending on what it's seeing, and then be able to collect the data together to be able to do that same kind of correlation. I don't know, John, what are you seeing?
Well, the flip side of that is drowning in data, which we heard from many organizations. I think there's a natural tendency to pack rat and collect as much data as possible and do that analysis to find correlations, but it generally dramatically increases the time to detection when you do it that way, which is bad for kind of the overall cost to contain. But I think that echoing what I said earlier, it needs to be both algorithms, which includes kind of advanced approaches to data science and machine learning that do better correlation, but also the quality of the data, and that's really where the traditional SOC falls down, because there's no real emphasis on improving the quality of the data, only on improving the quantity of the data and then the algorithms being applied to that data. It's much better to kind of supplement what you're doing today by getting deeper system level information to do detection on than it is. I would say that has provided better results, and Google did a public presentation where they said essentially the same thing, that improving the data quality and bringing deeper security expertise to that data was much more impactful than applying better machine learning algorithms. And if they only applied algorithms on the data, they didn't get very good results, and neither does anyone else.
Yeah, and I think that's true beyond just what we're seeing in security. I think generally we're seeing that a lot of the hype around AI and machine learning is being subverted by insufficient hype about data quality and data governance. So that's not only true in security, I think it's across the board. So I'm glad you're making that point about ensuring the quality of data. But it's also, again, relevant to a question here. It's not just about sort of reducing false positives. Correlation and contextualization of the data we get should also be about focusing on what's most important to the business, right? Because there's a difference between somebody's, some endpoint somewhere experiencing some kind of attack, and some attack that's actually on a crown jewel application that will give access to some back-end database that has all of our customers' PII, right? So do you want to talk a little bit about streamlining SecOps in a way that focuses on what's most important in terms of business value and risk, as opposed to just kind of treating everything the same? Either one. Whoever wants to jump in.
Well, I mean, I think that goes down all the way down to the base of the pyramid to discovery, where you need to understand the assets you're trying to protect, and that includes understanding the relative value of assets. I think where people have, we've been surprised at many organizations that they have focused their security operations efforts on their least valuable assets. They focus on the desktops of people walking around instead of their production infrastructure where the crown jewels are kept, because it's easier to get high quality data there that's actionable without, and they can't get that in production because they're worried that it's going to put everything at risk.
Yeah, I really agree. It's interesting that all devices are treated equally oftentimes, when really what you need to focus on are the assets of people who have direct access to the crown jewels, for example. And then once again, those applications where we're rolling out the red carpet that have access directly into customer data.
Yep. And we have another question here that's a little bit more specific about technologies. Specifically, John, I'll throw it to you first. You know, web application firewalls, runtime applications, self-protection, so, you know, WAF and RASP. Do you want to comment specifically on the adequacy or inadequacy of those technologies in terms of this kind of application level defense?
Well, I think that the industry is traditionally liked belt and suspenders approaches. If you look at any one method for doing detection, there are going to be gaping holes in it in terms of the visibility you're getting or the detection you're providing, and it's not always the quality of detection. So with kind of looking at the application level, for instance, I was talking earlier about account takeover problems where people steal real credentials, and that's definitely not something that you're typically going to catch if a login might be legitimate, and that's why we've got user behavior analytics as kind of a separate category of detection capabilities. So, you know, detection today is not handled by one kind of Uber detection. There are a bunch of different classes of detection. Another place where kind of the application level security falls down is in performance. If you want to do the best possible detection in the application, it requires a deep instrumentation, which comes with a really high cost, and so people often want to be selective about it because that turns to dollars, and that can leave you vulnerable. Another kind of example of the kinds of things you might want to do is, you know, system level detection, doing network level detection, looking at kind of how the application kind of behaves and uses the network, but the system that it's on, how it behaves and uses the network. So I think that there's a tremendous amount of effort in security organizations to use a bunch of different techniques, both trying to provide assurance during the software life cycle, trying to detect at the system level, trying to detect at the application level, and trying to detect at the network level. And then that's where kind of the additional layer of analytics that ties it all together is most valuable.
Yeah, that definitely makes sense across your belt and your suspenders and anything else, so that those are not disparate silos, but that they can be used kind of, hate the word, but synergistically with each other. Very briefly, Amy, we do have a question here. You talked about it some, but how container workloads are different than typical workloads. Can you kind of just briefly sum that up so that we have clarity with everybody here about the new implications of containers in terms of security and application workloads?
Yeah, you bet. So when you think about a typical monolithic application, it gets deployed on-premise or in the cloud, and if you put those kind of belts and suspenders protection around it, then there's not a whole lot of entry points that an attacker can get into. However, when you deal with something like containers, now you've almost exposed the innards of the application, and the communication between those different containers is exposed. Yep. Also, with the host operating system, any kind of vulnerability in your host operating system, your containers inherit it, which is very different than something like virtual machines where that isn't the case. So there are just some slight differences about containers that, are not typical of normal applications.
That's very, very helpful, and again, I'm sure we can explore more on that. We're coming to the end of our time. I think I want to give you each just a quick minute for any final words or exhortations or cautions. Amy, you can be first up. Anything you want to share real quick in closing?
Yeah, we talked about that highest peak being the nirvana. I think that's really the key takeaway here. Anything you can do to get to that highest level, building on the other levels to try to create automation where possible. We are not having a horde of bodies coming to save us. Automation is really the only way to respond to attacks in the future.
John, anything you want to share?
Yeah, I think that pragmatically, I realize that it takes a long time to get to the point where everything's fully automated for most organizations, but every organization more or less has a project going to move to the cloud and cloud native infrastructure, and I think that is the single biggest opportunity you have to rethink how you do security operations, figure out where you could be executing better relative to the hierarchy of needs as you move into the new world. And I think that for me, the kind of making sure the bottom of the pyramid is as firm as possible, making sure that you have the best quality data at the base of the pyramid, and then also better analytics that will make it a much kind of more focused problem for your investigation and automation needs.
Yeah, really appreciate you guys giving us kind of a coherent roadmap so we don't feel like we're boiling the ocean, but kind of putting data quality first and having this hierarchy of needs is super, super useful. Want to encourage everybody who's been on with us today, by the way, that you obviously want to share this link that you have on demand for this webcast if you have it now, or if it's coming to you in email, because this is obviously a collaborative effort. So encourage you to do that. If we didn't get to your question, by the way, we've got it here in the queue. We'll get to you offline. And, of course, if you found your time with us worthwhile today, please keep your eyes peeled for future eWeek presentations. So with that, on behalf of Amy and John, this is Lenny Liebman. Appreciate being your moderator today. Hope to see you again online soon. Have a great, productive, and safe day.